Hi everybody, welcome to my new channel. I will be doing mathematics from grade 10 to grade 12 on all different levels, reteaching and reinforcing and moving into more difficult examples for those of you who need it. And I hope that you will find something very beneficial from what we are about to do. Let's get started. This is the second worksheet I'm doing on trig identities. It's a bit more advanced than the previous one, still using the same formulas. We just now have lots of fractions. So I think it's easiest to do it in color. I have changed tan to sin on cos and 1 on tan to cos on sin. So I think let's work in colors. I'm going to do the numerator in green, and then I'll come back and do the denominator in red. Double-decker fractions, just take care. Right, let's go. Right, in the green bracket up at the top, I'm getting an LCD of sin cos, doing it in green, so I will be left with sin theta plus cos theta. Right, then we're going to go and do the red bracket. Right, and now I'm going to get an LCD for the red bracket, which is also sin theta cos theta. And cos cancels, so I'm left with sin squared and plus cos squared, which is a formula that we recognize. It is a formula, sin squared plus cos squared is 1. Right, carrying on, we're going to tip and times those brackets. Right, tip and timesing the red bracket, I'm going to get sin theta cos theta on 1, and the 1 comes from that sin squared plus cos squared. Right, and then the sin cos cancels with the sin cos, and I am left with what I wanted, the right hand side, which is sin theta minus cos theta, left hand side equals the right hand side, and that is done. Just to highlight quickly that the tan, let's just change that color so you can see, tan becomes sin on cos, and 1 on tan becomes cos on sin. Other than that, it's getting LCDs, tip and times, never tip and times individual. You can only do it once you've done an LCD. Right, this next question has an incredibly important concept, and that concept is to recognize when you have got sin 2a plus times, sorry, let's try that again. When you've got 2 sin a cos a together with a constant, then we have a very important process, and that process is to take 1 and make that sin squared a and plus cos squared a. Right, and then put the plus 2 sin a cos a in the middle. Right, very important to recognize that. Right, so when you have a mixture and a constant, you take the constant and you go backwards from sin squared plus cos squared is 1. You go that 1 is sine squared plus cos squared. In doing that, you have created a trinomial or quadratic, which will factorize. If that number isn't a 1, let's say it's a 7, then you would put in 7 sine squared, 7 cos squared. So whatever the constant is, when you have a mixture, you need to form a quadratic. Right, so what we're going to get on the top is sine A plus cos A plus cos A all over sine A plus cos A, which we can put in a bracket and cancel, and then our answer is the right hand side, sine A plus cos A. Right, so this is quite a popular concept, so let's fill in everything that we need to do. Right, so those cancel the brackets, denominator and numerator, and I'm left with the right hand side, sine A plus cos A. Therefore my left hand side equals my right hand side. And very important, you check the right hand side before you even start, because that there is your guide. Remember, they give you a left hand side and a right hand side to guide you. So I see mixture on the denominator here, mixture on the right hand side, mixture in the middle, so I change my constant to the mixture of sine squared plus cos squared, and it gives me a quadratic. So this comes up quite often. We'll do quite a few. Right, the next one is another concept question. If you have a look at it, there's really nothing you can do with it, because you cannot use square identities because there are no squares, and you cannot use tan into sine and cos because there's no tan. So it doesn't matter which side you work with. I'm going to work with the left hand side, but it will work equally well with the right hand side. So I'm going to take the left hand side, which is 1 minus sine beta on cos beta, and I'm going to multiply it by the conjugate pair of the binomial, so that would be 1 plus sine beta on 1 plus sine beta. So I'm actually multiplying by 1 in disguise, and I've used the conjugate. Right, so on the top I have 1 minus sine b, 1 plus sine b. So if I FOIL that out, I get 1 minus sine squared b, and I now have picked up one of my formulas. On the bottom, don't multiply the cos b in, because it will defeat the object and make us have to do extra lines. Right, so now 1 minus sine squared is cos squared on cos beta into 1 plus sine beta. Right, so what I have done is cancel the coses, and I'm left with a cos on the top and a 1 plus sine on the bottom, and therefore my left hand side equals my right hand side. How do we recognize when to do this? Well, if you look at the original question, none of these are squared, so I cannot use my square identities, and I don't have tan. It doesn't matter which side you work with, you are absolutely stuck. So what you have to do is multiply by 1 in disguise, and always use the opposite sign, and then what you do top, you must do bottom, because what you have done is you have created the conjugate pair, which gets back to dots. And then the dots is a formula. 1 minus sine squared gives you cos squared. And then the cos's cancel, and you are left with a cos on 1 plus sine. You could have done the other side if you wanted to. You would just do the conjugate of 1 plus sine beta, top and bottom. But very important that that green bracket is 1, because multiplying by 1 is not changing anything. Use the opposite sign, and then you will pick up 1 minus sine squared, which is a formula. It's cos squared, and everything works out beautifully. So let's hope that you understand that. We'll move on to the next question. That's it, and I hope you found this lesson very helpful. Please subscribe to get regular updates on future videos, and leave a like and a comment. And if there's something in particular you'd like me to cover, please let me know. And please share with anybody out there who you think would find these lessons beneficial.